All right, I need to simplify this statement down. First off, I see there's a negative here. So I'm going to make this into 6b to the 4/3 power, just to get rid of that negative. Now I can look at the 4/3 power. So this is the fourth power, so 6b to the fourth power, and then the cubed root. That's what the division by 3 power means. So the cube root of 6b doesn't do anything, right? The cube root of 6 can't simplify that down. Cube root of b can't simplify that down. We can, however, put them to the fourth power first. And so that's going to give us 1 over 6 to the fourth power times b to the fourth power, and then do the cubed root. Because you can do it in either order. You can take the cube root first, or take the fourth root first, or fourth power first, and then do the other thing you need to. You always get the same answer both ways, but some ways actually lets you simplify it a little bit nicer in the algebra. Here I can take out 3 to 6s because there's 3 times 1. So this is the same thing as saying the cube root of 6 cubed times the cube root of 6 times the cube root of b to the third power times the cubed root of b. Just splitting up the numbers so that the perfect cubes in there. And that's going to give me 1 over 6, then there's a b there, times by the cube root of 6b. Now, I can actually rationalize this denominator if I multiply the top and bottom by the cube root of 6 squared b squared. The reason why I have to do 6 squared b squared is because 6 squared times 6 is 6 cubed. And we can combine the b squared times b, that makes b to the 6th power. So, or sorry, b to the third power, and then the third root and the third power cancel. So that's actually going to end up canceling everything, the radicals in the denominator. So on the numerator, I have to do the same thing. So it's going to give me the cube root of 6 squared is 36, b squared just b squared. And then here I'm just going to get 6b. 6b times 6b is 36b squared. And you could say that is simplified.